Hola, buenos días. Hello, welcome everybody. Thanks for attending my speech. I'm Estela, and I'm going to be talking about the Peter Moss AML, ALL, AI research project. I guess most of you are coming here expecting some code lines and stuff, but this is going to be an accelerated biology class. This project started with Peter Edward Moss having a blood test, and this test turned out clear. After this, he collapsed. Doctors didn't know what was going on. After that, he was diagnosed with acute myeloid leukemia. Peter's grandson, Adam, was trying to find out what kind of leukemia was, as well as his family. And unfortunately, there was no information available, or the amount of information was pretty limited for the understood. Adam, his grandson, had previously created a model to diagnose ductal carcinoma by CNN. And after that, he decided he wanted to get more involved into leukemia and was trying to adapt this model into this type of cancer. Adam is pretty active in social networks as Facebook. And with this initiative, he could contact with Professor Ho. He's from the University of Kansas, and they both started this project about AML. This project has attracted nowadays a lot of volunteers from all over the globe, and as well, like 2 weeks ago or something like that, we started a student program based on this project. Unfortunately, Peter Edward Moss passed out a month ago. Now this project will keep on going for further families who would like to know about this kind of disease and to get AI into this medical background. Now I'm going to introduce you a little bit of the most active team members. This one here is Adam. He is the founder of the project. He is an IoT engineer, and well, he's been as Intel Software Innovator for many years now. And he's been participating in many research projects with them. And with that, he introduced us to Intel as well. Professor Ho, he is also a co-founder and also an Intel innovator. And he is professor of proteins in the University of Kansas. He has a drug discovery program as well, which I will be talking about it a little bit further in this presentation. Dr. Amita, she is an associate professor in the Department of Electronics in Delhi, and has been actively working in machine learning and intelligence in the last 20 years, as well as she wrote a book which was published, I think, a few months from now. This is me. I'm also a software innovator from Intel. Salvatore Railei, he is from Italy. He is getting his PhD in bioinformatics. and as well as participating in research and development in this project. And finally, we have Rishbab Banga, also an Intel innovator and an active member of this project. About me and why I told you this is going to be an accelerate biology class, it's because I'm just graduated in biotechnology, which means that my background in programming is a bit limited, but still getting into this new world. I started my degree in 2014, working in many labs. I worked in genetics, in chemistry, and basically treating different kind of cellular samples. After that, in 2018, I realized the huge amount of information we were getting from labs, so I needed to know how to treat them instead of doing it by hand, which takes ages. I wanted to do it in a computational way. In 2018 as well, it's when I met Adam in the company where he's working right now, and he told me about his carcinoma project. I was interested because in 2019, I was getting my bachelor's thesis, and I wanted to do something different. Finally, this year, I turned in my case study on Peter Moss. What is leukemia, and what is this large name that it has? Leukemia can be classified in two ways. In the speed of progression, which is acute or chronic, and then we have the type of white blood cells that are being affected, corresponding to lymphocytic or myelogenous. As well, when we started looking for data sets to implement our detection system, we found out there was no AML, so acute myeloid leukemia data sets available, public ones, of course. So we based this project in ALL, so acute lymphoblastic leukemia. Acute lymphoblastic leukemia is characterized by an overproduction of abnormal white blood cells. As you can see, there's 3 different ways to classify ALL, affecting according to its affectance over population. What you see here in the right, it's an image, it's an example of what we are using for our detection system, This data set was provided by Fabio Scotti from the University of Milano. And you can find more information about him if you want in our website. Unfortunately, there's many ways of finding out which kind of cells are good, which kind of cells are bad. But staining is not a possibility because all cells are different and dyes affect differently to cells. Dyes are the ones which are colored with purple. So these would be the ones affected by leukemia. So what's the project about? We have a GitHub page, which is being actualized every time that we find something new, every time that we get some ideas, we get some information, and we have the most important part, which is an archive. This one contains different information, related centers, where they study this type of cancer, a code archive, where you can find the code source, and data sets, as the one I mentioned before about Fabio Scotti. And then we also have a drug archive, where you can find how different kind of drugs affect each type of cell. the most important part, I think, for you. It's this one, the classifier and how it works. So it is a collection of projects with different type of classifiers as TensorFlow, Caffe, FastAI, Intel Movidius, OpenVino, and then also different script languages as Python, Java, C++, and a new one, R. R is really used in medical backgrounds for data treatment. This one here, it's the part of the project based on drug discovery. As I mentioned before, Professor Ho is the one leading this part. It's based on generative adversarial networks, and he and his laboratory designed the organic program, which is based to find which kind of proteins and which kind of cells attract better to different kind of drugs. We also have the part of the detection system, which I'm not going to demo today because I don't have the necessary equipment. Adam is the one being more active in this part. And we had demoed it twice, once in Embedded World in Nuremberg, Germany, and I've also talked about it in the Affinity Day in Munich, based on Intel offices. A really important thing, and that we are really proud about this project, is that it was voted first in Europe out of 4 projects and awarded with the Intel DevMesh AI Spotlight Award. A few weeks ago, we had published this student program where people like me are able to join the project. It is completely volunteered, and the 2 mentors we have are Ho and Amita. They both work hand by hand to provide tools and courses to students that want to implement this kind of technologies to biology and, of course, engineering. Both are Intel Software Innovator. I keep on repeating this one because it's really important for us, because this program has allowed us to improve in this project. Finally, Facebook has this new thing where you can impulse fundraisers, and the last month we got a total amount of 945 euros for the cause. Each year this fundraiser is going to be open, and the benefits are going to be split in these 2 entities to keep on researching. As I mentioned, Intel allowed us with these technologies to do the detection system and classifiers in a faster way, and it has published us in different events. And well, I think it was quite fast, sorry. But thank you for listening. If you have any questions about it, about the project, about where to contact, you can ask them now. You can write down the contact email, which the 6 team members I mentioned before are going to answer you. Thank you. There's any questions for the people here? Yes?
Okay, if I'm going to start in the project, when should I start? So, first step?
The first step would be emailing to this address with a little bit of description about you and where could you fit in the different parts we have in the project. Which is your background?
Mostly full stack developer, web developer, but I'm interested in other things.
Okay, perfect. So just write an email, and Adam will answer you because, well, he's the most active, but anyone will do.
Okay, thank you.
Yes?
You mentioned that you don't have access to a public data set regarding the first kind of leukemia, right? But
Yes.
my question is,
Are you working or collaborating with any institutions or whatever to get access to this data or collecting it?
Well, the problem about that is that we work completely on open source, so this would be available for anyone who would like. Research institutions need to put money to get these data sets, and of course it's from patients, so it's sensitive data, and it's pretty difficult for us to access to those.
So my question is, this data exists, but it's not available for
Accessible.
public access, or it just doesn't exist?
No, it's difficult to access to this one. I bet it exists.
Thank you.
Someone else?
Any questions?
Yes, regarding to that, when you say that it's difficult to access that, in your case, for example,
Yeah.
how did you? It was a matter of a chance that suddenly you got access to this person, or it was more like a matter of work it a lot and finally you got some, you got this contact and then you got.
Well, it was when Adam and Ho got in contact through this Facebook group from people being affected from leukemia. Ho had already access to this data set, so he provided us with Fabio's email and contact to get this data set. For that, we also been trying to get access to different ones, but of course it's not a website that you can just log in and download the data, so it's more tough to get. Does it answer your question?
Yes. This is because in our case we're trying also to get some data from hospitals, and and you can't do it as a private company. You have always to go through research centers, and those research centers or technological centers, even they have it very difficult. So that was a little bit that's why I was doing that question.
What are you working on?
There are research projects about how people behave, or how what data can we get with this kind of wristbands and everything. So
Yeah.
steps and dreams and sleep hours. So what information can we get about that?
Well, I think this would be the same because of the sensitivity of this kind of data, I guess. Because it has like a fingerprint, right, that you can get back to the person in question. So the same would happen here. Well, and of course we are not we are starting to be an official research program. I think before summer we didn't even got this kind of attention, but now with the Fundraiser and everything, we are getting more and more people attracted to the project and hopefully more data to research on. Further questions? Someone else? So is everyone in here based in softwares, or there's anyone with kind of medical background, biological background? No? Well, so I hope you could follow this presentation, and I hope you got the main message, which is that this kind of information needs to be more public and more open so anyone can access it. And of course, I'm not against private entities, please don't take me wrong. But this would be nice for people like Peter's family who try to get more information about a disease, and it's not only medical records or something like this. Thank you.